Hello children, how are you all? I hope you are all doing good. Welcome to another session of digital classes. Metals means what, children? Metals are hard solid substances which are not found in the free states except of some metals like gold and silver. Most of the metals are found in the earth's crust combined with other impurities. So, they are called as minerals, and we extract metals from ores because ores are the minerals from which you can extract the metals profitably. So, extraction of metals mainly has three stages to be followed, children. The first stage is concentration or dressing of ore, and the second stage is extraction of crude metal, and the third stage is refining of metal. Concentration of ore means the process of removing impurities is called as dressing or concentration of minerals. Now, this is the way you are selecting a particular ore, you are putting it into a vibrating feeder. By using jaw crusher, you are crushing it into smaller pieces, you are grinding the ore into smaller pieces by using a ball mill. And then concentration of ore takes place by using a magnetic separator. Now, children, this is the way you are extracting copper metal from its respective ore. So, the impurities like sand and clay which are present along with the metal are called as gangue. Children, what is gangue? As I told you, the ore is obtained from the earth's crust. So, it is combined with sand and other impurities. So, during the concentration of ore, we are cleaning the ore. After crushing it, we are dressing the ore, we call it as ore dressing. So, what are the impurities which you are removing? They are separating from the pure ore. These impurities are called as gangue. So, sand and clay are removed from the ore. That impurity is called as gangue. So, if you look at this picture, sand and soil can be clearly seen, and that sand and soil is nothing but the impurity present along with the ore, that is called as gangue. So, children, in metallurgy, we concentrate the ores by the different methods. The first method we are going to study is hydrolytic method. In this method, we pour the ore over a sloping, vibrating, corrugated table which has grooves on it, children, and then a jet of water is allowed to flow over the surface. What happens when you allow the jet of water to flow? The heavier particles will stay back and the lighter particles will move along with the jet of water. Now, the denser ore particles settle in the grooves, isn't it? The heavier particles will settle and the impurities are washed away. The lighter particles or the lighter impurities are washed away and the heavier ores settle down. So, if you see this picture, children, this is the way hydraulic washing is taking place. So, from here, the fine ore particles are being poured, and here through this pipe a jet of water is allowed to flow, and this ore, fine ore particle gets mixed up with the water, and you can see the lighter impurities, they move along with the jet of water, and then the heavier ore particles are separated. In this way, concentration or dressing of ore takes place by using the help of water. This process is called as hydraulic washing. Now, let us see what is magnetic separation. Magnetic separation, here we are using magnets. So, that means we are mainly using this method where magnetic impurities are there. So, magnetic separation, if you see, in this case the crushed ore is placed on a conveyor belt. This belt rotates around two wheels. There is a conveyor belt. Now, magnetic ores like magnetic metals like iron, they get attracted to the magnetic belt. They move and they fall near the magnetic belt, and the impurities which are non-magnetic, that means which do not get attracted to the magnet, they go away moving along with the magnetic belt and they fall away from the magnetic belt. So, there are two wheels on which a magnetic conveyor belt keeps on moving, and this magnetic ore, when it is allowed to fall on the belt, the magnetic substances like iron, the substances which are getting attracted to the magnet, they move along with the belt and they fall near the first wheel. And the impurities which are non-magnetic in nature, they go along with the belt but they fall away. See this picture, children? Here these are the two wheels. From here, from the funnel, the ore is allowed to fall on the magnetic belt, and as I told you, the magnetic substances, they fall near the wheel, and the other substances which are non-magnetic, they fall away from the wheel. So, in this way magnetic separation can be used to ore dressing, for dressing the ore. The next is method which can be used for dressing the ore is froth flotation. In this process, we take crushed ore in a large tank. Froth means what? Froth is nothing but we call it as foam, isn't it? So, we are taking the crushed ore and we are obtaining froth. So, in this process, we take the crushed ore in a large tank which contains oil and water, and then a current of compressed air is passed through it. The ore gets wet by oil and is separated from the impurities in the form of froth, that means a foam. Ore is lighter and so it comes on the surface and impurities are left behind. So, what are the things which we are using here, children? Oil and water. So, in a big tank, when you are allowing the ore to settle down and mix with the oil and water, and you are allowing the air to flow through it, then the impurities and the ore, it gets mixed up and then it forms a foam. Look at this picture, children. This is a froth flotation process which is used to obtain metals from the sulphide ores. That means here the impurity is sulphur. So, children, look at this picture. Here we have taken the ore mixed with water containing pine oil and we are allowing compressed air to flow through it. Because of this air, it forms froth. Here sulphide ore is lighter, it mixes with the pine oil and it forms a foam, a froth in the form of bubbles. It contains sulphide ore particles. And what are all the impurities which do not, as they are heavier, which do not form froth, they settle down, and these impurities are called as gangue. So, in this way the froth which is floating on the impurities is collected separately. So, in this way concentration of sulphide ore takes place. So, children, let us see what are the different methods used for concentration of ore or ore dressing. First one, hand picking. Children, hand picking, the word itself tells us that you are picking the impurities and separating the impurities from the ore. Here hand picking can be done only when the sizes of the impurities are different, the colors are different. So, if the ore particles and the impurities are different from one another depending upon the properties like color, size, etc. So, ore particles can be hand picked and they can be separated from the impurities. Washing of the ore can be done. How? As we have crushed the ore and we have allowed the ore particles to flow along with the water. So, ore particles will settle down as they are heavier and the lighter impurities will go along with the jet of the water. And then the next method we have seen, froth flotation. In froth flotation we have taken mainly sulphide ores can be cleaned by using this froth flotation. Here ore particles are crushed and kept on a slopey surface, they are washed with controlled flow of water, and then less densive impurities are carried away by the water flow, leaving the more densive ore particles behind. Next, magnetic separation, this also can be used for ore dressing. If the ore or the impurity, one of them is magnetic substance, as I told you, mostly the ores which contain iron or the metals which get attracted with the magnet can be separated by using this magnetic separation. So, if the ore or the impurity, one of them is magnetic substance and the other one is non-magnetic, then this method can be used for ore dressing. So, here this is the way, here you can see the ladies are picking the ore and they are separating the impurities from the ore. This is the first method, that is hand picking. Next, washing. In this way the ore is settled down along the sloping table and a jet of water is allowed to pass. This is the way hydraulic washing of the ore takes place. Next, this is the way froth flotation we have studied, mainly sulphide ores are here ore dressing takes place by froth flotation. Next, magnetic separation, mainly the ores which contain magnetic substances can be dressed by using this magnetic separation. Children, ore is a mineral from which you can extract metals profitably. So, what are the steps we have seen? The first step is concentration of ore by different processes like hand picking, washing, froth flotation and magnetic separation. Children, extraction of crude metal from the ore depends upon the reactivity of the metals. Some metals are medium reactive, moderately reactive, and some metals are having low reactivity. So, we have also seen the types of ores. That means, if the metal is combined with a halogen, then that type of ore is called as halide ore, and if the metal is combined with oxygen, we call it as a oxide ore. So, if the metals are of high reactivity, they form metal halides or metal oxides. So, extraction of such highly reactive metal can be done by a process called as electrolysis. Now, children, if you are taking metals of medium reactivity, then these metals, they react with carbonate ion and form carbonate ore and sulphide ore. Then what are the different processes from which you can extract the metal profitably? Calcination and roasting. So, children, by calcination and roasting, you can convert carbonate ore into oxide or sulphide ore into oxide, and from this oxide of metal you can again reduce it and you can get metal profitable. Now, what about the metals with the low reactivity? They form sulphide ores by combining with sulfur. Children, the process from which you can extract the metal profitably from sulphide ore is roasting. By a process called as roasting, you can convert sulphide ore into oxide ore, and then after reducing the metal oxide, you can get metals profitably. So, after getting metals profitably from different processes, you can again purify them. And what is the method of purification? It can be distillation, poling, liquation or electrolytic refining, depending upon the metal you have taken. So, this is all about we have to study in this lesson. So, extraction of metals from the ore comprises of three main stages, children. The first stage is concentration, extraction of crude metal and refining of the metal. So, concentration of the ore should be done, and then from that ore you have to extract the crude metal. After getting the crude metal from its ore, you need to refine it by the different processes. So, let us see what are the different metallurgical processes that can be classified into. So, first thing is crushing and grinding. Children, the first process in metallurgy is crushing of the ore into fine powder. We can use a crusher or a ball mill, and this process is known as pulverization. Then concentration of ore. In this process, children, we need to remove the impurities from the ore, and this is called as concentration of minerals or ore dressing. We concentrate the ores mainly by the following methods: hydrolytic method, magnetic separation, froth flotation, roasting and calcination. So, these are all the different methods we have seen. Now, about froth flotation we have studied in the last class. Now, what is roasting? Children, in metallurgy, the process of heating a concentrated ore in the presence of oxygen is known as roasting. This process is applied in the case of sulphide ore. So, in roasting, what are we doing, children? We are heating the ore in the presence of oxygen. Now, if the ores have carbonate ion as impurity, so for ores containing carbonate or hydroxyl ions, then they are called as carbonate ions, or if the ore contains oxygen along with the water molecule, so they are called as hydrated oxides. Heating is done in the absence of air to melt the ores, and that process is called as calcination. So, we can take these many processes for extraction of crude metal from the ore. So children, the reduction of purified ore to the metal has 3 steps depending upon the activity series of the metals. Children, the first series if you take, then they are highly reactive metals. So metals with high reactivity or the metals which are at the top of the activity series can be reduced by different methods, and extraction of metals in the middle of the activity series, they involve different methods of extraction of ore. Then extraction of metals at the bottom of activity series. So in the extraction of metals, the activity series plays a major role. Now let us just recall the activity series, children. At the top of the activity series, you can see potassium, sodium, calcium, magnesium and aluminium. These metals are highly reactive. Then zinc, iron, tin and lead are moderately reactive. And if you take copper, silver, gold and platinum, they are least reactive. So extraction of metals from the ores, it involves the importance of this reactivity series. So reduction of purified ore to the metal. Let us take the first type, that is the metals which are present at the top of the activity series. They are potassium, sodium, calcium, magnesium and aluminium. Children, simple chemical reduction methods like heating with carbon or carbon monoxide etc. will reduce the ores to the metals. Now what is reduce, children? Reduction. Reduction means, children, oxidation is the process of addition of oxygen to the metals. Then what is reduction? It is the removal of oxygen from the respective oxide ores. So mostly the ores which have metal along with oxygen as the impurity, we need to reduce that. So reduction of ore will lead to the extraction of pure metal from the respective oxide ores. So children, we use carbon or carbon monoxide for reducing the metal oxides to the respective metals. So the temperature required for the reduction is too high or more expensive. Children, the metals can be extracted by a method called as electrolysis also. For example, to extract sodium from sodium chloride, we can use electrolysis. Now what is electrolysis, children? Electrolysis means the breaking of a particular molecule with the help of electricity. So sodium chloride is taken in the molten state, and then when electricity is passed through it by using two electrodes, one is anode and the other one is cathode, then the sodium ions will get separated along with the chloride ions. Now sodium ions means positive ions, so they get attracted to the negatively charged electrode, that is cathode. Chloride ions are negatively charged ions, so they get attracted to the positively charged anode. So we can separate sodium ions from the chloride ions at two different electrodes. So electrolysis is a process of separating the ions. Mainly here from sodium chloride we are extracting sodium ions. And what is the process we are taking up, children? Electrolysis. With the help of electricity, we are splitting the ions and extracting the metal, pure metal, profitably. So children, fused sodium chloride is electrolyzed with a steel cathode, negatively charged electrode, and a graphite anode. So cathode is a steel rod and graphite is a anode. Now the metal sodium will be deposited at cathode and chloride gas. Children, chloride ions will be deposited at anode, and this chloride ions, they will combine to form chlorine gas. So if you look at this picture, children, here this is the molten sodium chloride. Now if you are taking two electrodes, children, two electrodes, here graphite rod is anode and steel rod is cathode, and when you are passing electricity, this is the source of electricity, children, we are using a battery in this picture, and when current passes, sodium chloride will split into sodium ions and chloride ions. Sodium ions, as they are positively charged ions, they get deposited at the cathode. So here pure metal, pure sodium metal will get deposited at cathode. Then what about chloride ions, Cl minus ions? They get deposited at the anode, and here chloride ions will combine with each other to form Cl2 gas, chlorine gas, which gets liberated from anode. So children, at cathode what is happening? Sodium ions are taking up 2 electrons and forming pure sodium metal, and at anode chloride ions, they are combining with each other, releasing 2 electrons, and they are forming chlorine gas, Cl2. So from the above electrolysis, a large quantity of electricity is required to keep the ore in the molten state. Suitable impurities are added to the ore to decrease its melting point. So to decrease its melting point, we are adding some more impurities. So children, at cathode you can see the deposition of sodium ions, and at anode we can see the release of chlorine gas. Thus we have separated sodium from its impurity chloride ion. So now let us see the extraction of metals in the middle of activity series like zinc, iron, tin, lead and copper metals. Children, mostly these metals, because of their moderate reactivity, they form sulphide and carbonates. So the ores of these metals are generally present as sulphides or carbonates in nature. Therefore, prior to reduction of ores of these metals, they must be first converted to metal oxides. So children, reduction of metal oxide is very easy. So we have to take sulphides or carbonates and convert them into metal oxides. So sulphides are converted into oxides by heating them strongly in the excess of air. Now what is this process we have studied as? It is called as roasting. So sulphide ores are burnt, are heated up in the presence of excess of air, and this process is called as roasting. Thus sulphur combines with oxygen and forms sulphur dioxide, which is removed, and the metals combine with oxygen to form metal oxides. Now if you look at this example children, generally sulphide ores are roasted to convert them into oxides before reducing them into metals. If you see this cinnabar, cinnabar means lead with sulphur. This is an ore of lead, and the impurity present here is sulphur. Lead sulphide, when it is heated in excess amount of oxygen, we can see the formation of lead oxide, because lead is also combining with oxygen to form lead oxide, and sulphur is also combining with oxygen to form sulphur dioxide. Thus what we have done here children, we have removed sulphur impurity with the help of oxygen as sulphur dioxide, and we have seen that lead has formed a lead oxide. Now this lead oxide can be reduced. Reduced means what? Removal of oxygen atom. So thus the metal oxides can be reduced to form pure metals. In this way the metals can be extracted from their oxides, and the reducing agent what we are using here is carbon. So when carbon reacts with lead oxide, the oxygen impurity can be removed as carbon monoxide, and you can see pure lead is deposited. So look at this picture children, reduction of metal oxides with carbon. The oxides are reduced by coke. So coke means carbon children. This process takes place in a closed furnace at around 1400 degrees centigrade. So lead gets deposited at the bottom of the furnace and carbon monoxide escapes out as gas. Now reduction of oxide ores with carbon monoxide also can be done, mainly with iron oxides. If you take iron oxides, these iron oxides is an ore of iron, hematite ore. Now this ore can also be reduced by taking up carbon monoxide. Here carbon monoxide will remove the oxygen impurity present in this ore. Now this is also called as reduction, because here carbon monoxide is removing oxygen from iron oxide, and this leads to the formation of pure iron which gets deposited at the bottom of the blast furnace, and carbon monoxide gets converted to carbon dioxide. Children, auto means self reduction of sulphide ores also can be done. Children, in the extraction of copper from its sulphide ore, What is the name of this ore, children? Copper sulphide. Here, this is an ore of copper. The impurity present here is sulphur. Now, this ore is subjected to partial roasting in air. That means the supply of air is decreased and mostly stopped. Then what happens? Sulphur reacts with a little amount of oxygen and thus sulphur dioxide is formed. And this copper sulphide, it forms cuprous oxide. Now, the rest of the sulphide reacts with oxides. So, here what is happening? Sulphur dioxide is combining with cuprous oxide and excess amount of Cu2S, copper sulphide, is also present. And so, as we have stopped the supply of air, this sulphur dioxide itself removes the oxygen, because this sulphur reacts with the available oxygen in the ore and it forms sulphur dioxide, thus separating the pure copper metal. So, what we have done in this process, children? This is called a self reduction. That means we have supplied only little amount of air. So, when roasting is done in limited amount of air, then sulphur reacts with oxygen to form sulphur dioxide and copper reacts with oxygen to form cuprous oxide. Now, when we have stopped the supply of air, then what happens? The sulphur dioxide combines with cuprous oxide and it again reacts with copper sulphide, forming copper and sulphur dioxide. So, totally sulphur itself present in the ore has reacted with oxygen and it has directly liberated the metal. Let us recap what we have studied, children. We have seen the extraction of metal from its ore. It involves 3 stages: concentration, extraction and refining. We have obtained ore from the earth's crust and then concentration of ore has been taken place. And what are the different methods we have used for ore dressing, children? Hand picking, washing, froth flotation and magnetic separation. So, extraction of crude metal from the ore depends upon the type of ore. So, children, ores are mainly the minerals which are obtained in the earth's crust. So, extraction of crude metal from the ore depends upon the reactivity of the metals, and we have seen there are 3 types of metals reactivity: metals of high reactivity, metals of medium reactivity and metals of low reactivity. Mention 2 methods which produces very poor metals and impure metals. So, I hope you have understood the lesson, children. Please download the worksheets from SCERT website for better learning and good practice. Let us meet in another interesting session of digital classes. Thank you.